I started learning C# in the .NET framework shortly after version 1 was released, and delegates was a topic that I just kind of glossed over for a couple of reasons. The first being because there wasn't a whole lot of information available, and the information that was available was primarily targeted to people with a computer science degree, which was something that I did not have. The second reason was because I could never really remember the syntax. Now, whenever I would use events with a window control or something like that, that was always easy to do because the syntax is very easy to use. But as far as writing a delegate for my code, or an event for my code, I never really did that because the delegate syntax was always something that I could just never remember. And then around when .NET 2 came out, I finally decided to learn to use delegates, and I started adding them to my code and things like that. But then later on, in about 3 years' time, .NET 3.5 came out. And then the game changed. Now, I'm not complaining because any new change should be for the better. And that is the case with .NET 3.5 because there were two things added to the .NET framework and C# specifically. The first being the function data type. And in the .NET framework, it's called a func, but I'm not going to say a func because it's just a few letters away from saying something else. So I'm just going to call it a function. And the function data type allows us to basically create a delegate very, very easily. And that's one thing we are going to look at today. The second thing that came with .NET 3.5 were Lambda expressions, which just blows the delegate syntax out of the water, at least as far as I'm concerned. Well, that's enough of me talking about me. Let's look at some of the actual code. And the code we have here is basically what we ended up with at the end of yesterday's lesson. The only change is I added back the find names with E method. And what we are going to do is use the function data type, create a delegate using that function data type, and assign this method to that delegate. So let's do that. The data type is func, but once again, I'm going to call it a function, and this is a generic type. So we have to specify the data types that this function are going to work with. Functions always return a value. Just that's how it is. There's another delegate called action, which doesn't return a value. It just performs a particular action. But functions always have to return a value. So you at least have to specify the return value. In this case, this delegate or this function would return a Boolean value. But that's not good enough in our case because while find names with E returns a Boolean value, it also accepts a string value. So we need to specify the parameter data type as well, and we do so before the return data type. So we do string, comma, and then bool. So when dealing with functions, always remember that the far right data type, or the one at the very end of the list of data types, is the return type. Everything before the return type are the parameters. And we're not limited to just one parameter. We can have, I don't know how many, but it's quite a lot. We could do string, int, float, date time, int, string, whatever we could do. And this is going to be a perfectly valid delegate. Now, naturally, we don't need all of these parameters, but if we did, we could use that. So let's get rid of all of that. We just want string as the parameter and bool as the return value. And then we need to give our function a name. I'm just going to call it fn. That's typically what I use for functions. And then we assign it a value. Well, we simply just want to assign it the value of find names with E. So we'll just copy and paste that in. And there we go. We have created a delegate. And we did so without specifying the delegate and then using that delegate type within our code. And if we wanted to call this, all we would have to do is use our variable name, fn, pass in a string value, and then if we wanted to, we could assign this to a variable. So bool result equals fn, and then passing a string ae. Now this will return true because the find names with E looks at the index of 1 to see if it is an E, and then returns true or false based upon if it is an E. So result would be true, If we removed either of these characters, then result would be false. So that's basically how we can now create a delegate. And this is Microsoft's preferred way to do so, is to use the function data type. But unfortunately, we cannot pass our fn variable to the findAll method because functions are not compatible with a predicate. So let's create a predicate string. We don't have to specify Boolean here because it's automatically done for us. Let's call this pred, and we will assign find names with E. They have the exact same signatures, but they are not compatible together. For example, we cannot assign fn to pred, and we cannot assign pred to fn. So if we are going to call the findAll method for our list of names, we have to either pass a predicate, which we just created, or an actual method that meets that specific signature, the delegate syntax that was there before, or we can use a Lambda expression. Lambda expressions are really cool because they're just shortened versions of the delegate syntax. So before we write a Lambda expression, let's look at the delegate syntax again. So let's rewrite our code yet again. Name index of E equals 1. Okay, so the first thing we can get rid of is the delegate keyword, so that's gone. The next thing we can get rid of is the parameter data type. The reason being because that is specified by our predicate. We have to specify the parameter data type. It's string, so string is automatically inferred here. And then the only addition we have to make is the double arrow. It's an equal sign followed by a greater than sign. So it kind of looks like an alligator chomping on something or whatever you want to call that. But this is a Lambda expression. It's a little bit shorter than the delegate syntax. And in my opinion, it's a lot easier to read. But we can even shorten this some more. This is a long Lambda expression. We can shorten it quite a bit. And the first thing we can do is change the parameter name. I usually change it to whatever the first name of the data type is, or whatever it is that I'm going to be using or passing to that parameter. So instead of name, I could do S or N. I'll just go with N for short for name. We'll change name to N. We do not need the return keyword, and we do not need the curly braces. So what we end up with is a very shortened version. Oh, and we don't need the parentheses as well because we only have one parameter. So instead of having the delegate syntax or even the long Lambda expression syntax, we can have something that is very nice and terse, and we can even just pass that to the findAll, and there we go. If we run this code, we are going to get the exact same results that we got before, and we did so writing less code using a Lambda expression. Now, Lambda expressions are not limited to predicates. These are little mini methods. They're delegates. So we can assign them to anything that accepts a delegate. And function is a delegate, so we can paste the same exact code because they both have the same signature. But naturally, we still can't use our function for the findAll method. But, do we really need to do that? Because the Lambda expression is so simple. And you also might be wondering why we got rid of the return value. Well, this is a very simple Lambda expression. There's only one statement in here. And as long as that statement results in the type of data that the return value is supposed to be, we don't have to use the return keyword. But if we have a multi-line Lambda, which we can do, we first have to specify the brackets or the braces, the curly braces, and we could have something else here, string blah equals whatever. And this would be a perfectly fine Lambda expression as well, but then since we have multiple statements, we do have to specify return. So if you want to have multiple lined Lambda expressions, you will need to use the return keyword. Otherwise, you can omit it and just have the expression. So very quickly, let's look at what happens if we have a delegate that is supposed to have multiple parameters. So let's say that this is going to have int and string, and it's going to return a Boolean value. So we'll call this fn2, and it's going to have an integer. We'll just call it I. It's going to have a string. We'll call it S. We'll have the alligator chomping, whatever you want to call it. And then let's just, have true. Now notice we are getting red squigglies here. And that is because the compiler is getting kind of confused with this little syntax. So to fix that, all we have to do is wrap that within parentheses. So it's kind of like, actual parameters. The I for the integer and the S for the string. And then we can use the lambda expression as we would need to. And we can do the same thing. We can have a multi-line, but then we would have to specify the return statement as well. So hopefully with functions and lambdas, you can see that .NET 3.5 added a lot of cool things and made delegates a whole lot easier to use. Tomorrow we are going to talk about another feature that was introduced with 3.5, which is called link. It's awesome. And once you use it, you will never want to go back. There's primarily three implementations of link. One is link to SQL, which allows easy interfacing with a Microsoft SQL server. There is link to XML, which is used for parsing and generating XML rather easily. And then there's link to objects, which is what we are going to talk about tomorrow, which allows us to do a lot of cool things with collections and some other data types. But that's going to sum us up for today. I will see you tomorrow. Have a good one.